So I'm going to talk about a thing called IPv6. There's going to be actually quite a lot of internet history in there, and there'll be a little bit of Raspberry Pi, not too much. This talk is more about why IPv6 is interesting as a Raspberry Pi hobbyist rather than any real hands-on stuff with a Pi. So I'm going to be talking about the internet, and there's lots of different ways that you could define the internet. For the purposes of this talk, the internet is computer systems that are connected together using a thing called the Internet Protocol, which is what I'm going to be talking about. So there's things you do on the internet: Netflix, Tinder, send email, shopping. There's protocols like HTTP and DNS. And if you're a normal person, there's those things. If you're a Pi person, you might do.
Yeah.
Are you saying, was someone saying something? No? Okay. If you're a Pi person, you might be doing art or playing with temperatures or spy cams or whatever your different projects are. And then at the bottom, there's different ways that you might be connected to the internet. So my laptop's on Wi-Fi, my phone is on 4 or 5G. My first internet connection was dial-up. There's various different ways. And they work together through this thing called the Internet Protocol. So if I'm doing some online shopping, that goes through the Internet Protocol and goes over ADSL. So Amazon doesn't need to know, am I using ADSL or dial-up or Wi-Fi? They just need to know that there's an Internet Protocol connection. And in the same way, my home ISP that's providing me Internet Protocol over ADSL doesn't need to know if I'm using Netflix or sending email or anything like that. So in 1969, this is what the beginnings of the internet looked like. So one of the prototypes was called the ARPANET. 1969, for context, is one of the last years that British Railways used steam locomotives. So as steam locomotives were disappearing, the internet was starting to appear. And this is a hand-drawn diagram of the first 4 nodes. The 3 of them are in California, one of them's in Utah. And they're numbered 1, 2, 3, and 4. So those numbers have a technical meaning. That is how, if someone at node number 1 wanted to send something, communicate with something at node number 4, they would use those node numbers 1 and 4. And so everything on this network, or at least the things in the circles on this diagram, has to have a number, an address. So here's a graph of how that network grew over the years. So in 1969, over on the left, there's 4, as that diagram was. And over time, in the 1980s, getting onto 1,000, about now, we're up to about 1 billion devices. So all those devices on the network still have to have some little identifier. Like on the first diagram, they were numbered 1, 2, 3, 4. Every device, all of those billion devices, has to have some kind of identifier as well. And that's called the IP address, the Internet Protocol address. So they use the big scheme that's mostly used now is called IPv4. And that really went live in 1983 when there were about 1,000 hosts on the internet. And IP addresses for version 4 look like this: 4 numbers, dom, 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 separated by dots. That's how they're written by humans usually. And those are 32 bits. So a bit is a number 0 or 1, or true or false or whatever. And so 32 bits means there's about 4 billion potential addresses. But they can't all be used because there are sensible reasons to not use them at 100%. So what can use these addresses now? Well, anything that runs Linux, Windows, Android, OS, things you can browse the web on, for example, Raspberry Pis, of course, if you've got an Alexa in your house. On the other side of things, all of the web servers, Netflix has loads of servers that stream video to you, your router in your house, for example. All of these things that want to participate in the internet, they all have to have an address. So just looking around my house, I can see 2 routers, 4 Raspberry Pis, 2 phones, 1 laptop, 3 temperature probes, network connected temperature probes, and then maybe visitors turn up as well. And then out in the cloud, I've got things providing my own email. So I have my own email server, which has an IP address. I have my own web server, which has an IP address. And I've got some DNS servers, which also have IP addresses. So you might expect a person to use a couple of IP addresses, a phone and a laptop, one for their house, for their router, for example. So a handful of addresses per person. If you look at the population of Earth, at the moment, it's about 7 billion. There's only 100% utilization, 4 billion IP addresses. So we're going to run out. And in 2010, was the first time when they really started running out. So there's workarounds. The most common one is that in your home or your office, every device in your network gets given a fake IP address, and your router has one real IP address that it somehow shares. Everyone in your house will share that IP address. So the upsides there, you can have hundreds of devices just using one IP address. The downsides, though, which are frustrating if you're a sort of hobbyist geek that wants to run your own web server, for example, is there's now 2 kinds of device on the internet. There's the ones with a real IP address, and there's ones that are behind this kind of home router NAT setup. So you can't, for example, run your own web server behind a NAT box very easily because it doesn't have a public IP address. So there are workarounds you can do, but they're a bit awkward. So you don't have this ability for any device to just talk to your home Raspberry Pi and download files from it, or look at web pages you're serving, or report data to it if it's, say, the central server for a sensor network you've built, or things like that. On the commercial side of things, on the server side of things, less relevant to your home hobby, being a home hobbyist, to get better utilization, people trade IP addresses now. So if you want to get one for Amazon, they charge about £3 a month just to be allowed to use a particular address. So the other thing you can do, which doesn't involve a NAT box and all sharing one address, is you can move on to IPv6. There are quite a few changes there. The big relevant one is that IP addresses are much, much longer. So instead of 32 bits with addresses, there's now 128 bits with something like 3 and 38, I think, zeros after it, possible addresses. So I was trying to get a good example. It's enough to give every bacteria cell on Earth 100 million addresses each. So there's a lot of addresses available now. In practice, that's split up as 48 bits identifies the organization the addresses belong to, 16 bits identifies the network, and then 64 bits identifies the machine on the network. And I'll show you some examples later how that works. But this line in the middle, 2001 8B0, that's an IP address on one of my home networks. So if you're doing that now, you can give all your devices a public IP address, just like in the olden days. And for example, the Raspberry Pi that sits on my shelf can talk to the Raspberry Pi that sits in my parents' house. So me and my dad have an arrangement where we have Raspberry Pis in each other's houses, and we do backups to our devices. So his Raspberry Pi sits on my home network just in front of me now. From his home network, he can just connect to the one here because they both have IP addresses. They can talk to each other. Another interesting example is there's a company called Mythic Beasts. They will host Raspberry Pis, so you can pay them to have a Raspberry Pi connected to the internet at their data center. That gets a real IPv6 address, and you can do the same kind of connection, but you don't get a public IPv4 address. So to connect to it over IPv4, you have to do a lot of awkward workarounds. And again, that will be because they're having to pay for IPv4 addresses and not for IPv6 addresses. So what does that look like? It might turn out that you already have IPv6. I'll show some statistics later, but this is a command prompt on my Raspberry Pi, one of them in front of me, called Spiral. And I've said, show me the IP addresses that are connected to your Wi-Fi interface. So I've typed in IP ADDR show dev WLAN 0. That says, show me the IP addresses that are attached to the internet device, to the network device WLAN 0, wireless LAN 0. And I'm not sure if you can see my mouse cursor, but there's INET 9155.94.91. That's an IPv4 address that it happens to have here. And then these three highlighted ones are three IPv6 addresses, because there's so many IP addresses in the world in IPv6, it's quite common for devices to have several. And I'll explain where those three have come from in another slide. So that might not happen. You might have to tell your Linux installation on your Pi that you want to use IPv6. And commonly you can do mod probe IPv6. We'll load that code in. And if you've got IPv6 on your network, then this sort of stuff will start happening. Or you might not have IPv6. When you've done that, there's not much else you can do. If your home network already has IPv6, it's very likely that Google or Facebook, you'll be using that without even knowing particularly that you are. If you want to get an ISP that does have IPv6 in the UK, I can recommend Andrews and Arnold. They're very geeky. They're a bit more pricey, but they have very good IPv6. Lots of software will already use this. So web browsers, absolutely. If you're on IPv6, you won't even notice you're using it. I'll show SSH in a minute. If you want to have people connecting into your own servers, which you can do now because you have loads of addresses, you might need to play about with your router firewall a little bit. And you can put an address record in the DNS so that you can have a name instead of people having to type in IP addresses. Okay, so when I said you might already be using IPv6, this is a graph from Google that I got today of the percentage of their network traffic, which is IPv6. So the rest of it is IPv4. And you can see down in 2010, nothing was using IPv6 in any significant amount. Everything was the older IPv4. But by now, today, they're at about 35% of their traffic is IPv6. So you might say there's a 35% chance that your network already has IPv6. We could say that. That's a very rough estimate. I know where I am, my mobile phone has IPv6. My two internet connections both have IPv6. So I showed those addresses earlier that are on my spiral display Pi in front of me. So the top two are the public IP addresses. One of them, the longer one, is automatically allocated. So this first bit of the prefix is 2001-8B0-1638 is allocated to me personally. The 98 is a number that I chose out of 65,000 possibilities for my particular home network. And then I chose number 3 because it's the third Pi in my house. So you put those together, you get this second IP address. So it's got the same up to 98 because it's on my home network, and the second bit changes. And the other one is this link local address. If you just put devices on a link, they will on a network together, they will just be able to talk to each other only on that same network using one of these automatic addresses. It won't work publicly, but because it doesn't need to be coordinated publicly, it means it can be done completely automatically. So I'll do a little bit of demo. There's not a lot to see that doesn't look like what you probably see is that this just looks like making a normal network connection. So I'm going to SSH, turn on verbose mode. Can you see that I've changed my screen to a shell prompt? Just checking. Richard. Yeah. Okay, good. Okay, so I'm going to SSH to, well, actually, let's first do this. I'm going to say, so I've got a Raspberry Pi called spiral.hawaga.org.uk, and it's got an IPv6 address. Okay, that address that I just showed earlier. It doesn't have an IPv4 address. So if you try to connect to it from an IPv4 only network, you won't be able to connect to it. If you connect to that spiral.hawaga.org.uk from IPv6 with a web browser, you'll be able to play with the lights that are on in front of me because it will give you a menu page. So I'm going to SSH into that. And it just connects, nothing fancy. You can see that my login is also from an IPv6 address. That's the IPv6 address of my laptop. But other than that, this is just a normal SSH connection. Nothing unusual at all. Okay. I'm not really sure what else there is to show because it just works. It either just works or it doesn't work. But I will show you a different computer. Let's try this one. You can see that this one hopefully has an IPv6 address and it has an IPv4 address because I happen to have that on a network which has public IPv4 addresses. So you can connect to this from either IPv4 or IPv6. Okay, so hopefully you can see there that there's some geek value in this, which might be useful to the kind of person that likes to play with Raspberry Pis at home. Does anyone have any questions?
It's Brian here. Can you hear me? Can you hear me?
Yeah, Brian.
Hey, just quickly, that first three sets of values on IPv6, is that you said that's usually the company or the ones that you've got designated? Does that come from centralized kind of register or something like that? How does that get assigned?
Yeah, so it's kind of hierarchical. Here, this.
Yes, the first, yeah, exactly. So does that come from like an internet kind of organization?
Yeah. So there's an authority called the Internet Assigned Numbers Authority, which sounds very glamorous. Up until 1998, it was a man in the office next door to me, one man, and they allocate chunks of this address space. So that central authority allocates to an organization called RIPE, which is the European IP Address Authority, and they will allocate onwards. So 2001 8B0 is allocated to my internet service provider, Andrews and Arnold, and they get to allocate anything under that space to their customers. Okay. So it's a hierarchical allocation. And
do you kind of pay for that allocation then?
No, it
comes with your ISP. Okay.
Yeah, the idea is that there's so many that it doesn't need to be a chargeable thing. Okay. Because there's infinite.
Yeah, my internet is Virgin, and I mean my IP address, even though I don't pay for static, it doesn't change. You know, it changes once every 4 years or something. So
yeah. So this 2001 8B01638 is, as long as I'm a customer with Andrews and Arnold, that will be my my address.
Yeah.
That just comes with my connection. And then under that, I have this big space of 70
Which you then control. You don't need to go through ISP. So you
Yeah.
they do
Anything
that
that
top
goes to
level.
this comes to my router, and then this 98 is just a number I chose.
Yeah.
My
Okay.
whatever.
Understood.
Not sure why I just chose 1 that day.
Okay.
So
Thank
Ben,
you.
if your ISP changes your public IP version 4 IP address, that
Yeah.
doesn't affect your IP6 address?
No.
Okay.
Yeah. So the intention is that it's much more static. No, of course, ISPs aren't compelled to do that, but it is intended to be a much more static allocation.
Another thought occurs to me that in these days of concern about internet privacy and so forth, once you make your IPv6 address, public, it's everyone can see it.
Yeah.
Is that not a concern?
Yes. So very early on, that wasn't a concern when they started on this in the late 90s, I think, or the mid 90s. And then more recently, it became a concern. And there's been some work. So, for example, I showed you one of the IP addresses was a big, long, random looking one. That will change every hour, I think, or so that I get a different IP address there every now and then.
Okay.
So a few questions, Ben. I mean, it sounds actually really interesting. First question, which you won't be able to answer, but what I'm sitting here thinking is, will my ISP let me use IPv6 and have them route it?
And what was the second question? The
next question really is, it's almost a follow-on to the previous one about security and how you avoid someone doing a port scan and finding your Raspberry Pi.
So if you don't want that to happen, then usually like my home internet router is set up to not allow any of these connections that way. So the protection isn't coming from not having a name, it's not having an address, it's coming from traffic connections not being allowed to that address.
Okay, so how about the ISP question? I mean, you obviously can't answer it for me. My ISP is particularly strange. I use 4G as my internet. I live in the middle of nowhere, but I'm very fortunate to have a couple of mobile phone masts line of sight out of my front window. So I actually get quite good speed using 4G. And of course, I'm waiting for 5G when it'll be wonderful. But the issue I've got, or one of the issues which I think will screw it up, is that when you use 4G or 5G, they do double natting. So they nat from the internet to some kind of DMZ, and then they nat from the DMZ to me.
So this is all the horrors of that. This mess is what the IPv6 is attempting to avoid long term, right? So there are things you can do. There are you can do a thing called tunneling, which is basically like a VPN. But with a VPN, you're trying to get privacy. With an IPv6 tunnel, you're just trying to get IPv6 address space routed to you. And I have one of my home networks is routed that way to a server in the UK. And I think you would be able to do that, I think, through double NAT. I think that would work. And then you would have all the IPv6 address space you wanted on your home network.
I mean, that sounds extremely interesting.
I'll just say that if you're using 4G or 5G, then you're already on IPv6 anyway, because that natively is IPv6. So the reason you're probably seeing double NAT is because they're natting you out via an IPv4 address to access some of the address space that it needs to, but natively it is all IPv6. So you might find if you're accessing something via IPv6 that actually it's not double natting it. And you may also find that, I mean, the biggest problem is that they're not designed to be servers. So you're not ever going to be able to run a web server off a 4G connection natively without trying to route it, like tunneling it as suggested. So yeah, but you probably are already using IPv6, you just didn't realize it.
That gives me food for thought.
Yeah. Yeah, I'm not really proposing any solutions. I think I was just trying to stir up people's curiosity to play.
I think you've managed that one, Ben. The question now is, how do I play next?
Yeah, yeah. So the setup I have here is I have a home. I have, because I move a lot, I have a router that does a tunnel to Andrews and Arnold in England. And so that block of IPv6 addresses has followed me through 3 different houses in London and 3 different apartments in Berlin, through that tunnel. I pay about £10 a month for that. And then I have a bunch of stuff, little home servers plugged into that, which I wouldn't particularly advise for doing serious work, although people do, but it's certainly good enough for me playing around.
So Ben, if I remembered your long IP6 address, should I be able to ping it from my machine?
If you're on IPv, if you have a working IPv6 connection, then you should be able to ping that machine. And if you do not have an IPv6 connection, then you won't be able to ping it. So I can, for example, say ping spiral.hawaga.org.uk. There we go. Okay, so you would be able to do this if you have a working IPv6 connection. If you don't have IPv6, that will tell you something about no address or something like that.
Yes. So if I don't have one, what do I do about it? I'm on Virgin Media.
Get a better ISP. or you can do what I do, which is overlay my own tunneled network over the top, which is like a VPN. So that was the thing I was saying earlier. But I paid separately for that. Or you just wait a few more years. Okay, so there was that graph where I was showing Google's take up is up to 35%, rapidly increasing. It will just naturally appear in your connection sometime in the next few years.
So I'm looking on a the Linux box I've got next to me here, and if I do ifconfig, I can see that the LAN connection does have an INET6 address.
What does it begin with?
FE80.
Okay, so these are. Let me show you this slide again. Oh, here we go. Can you see here? I had these 3 addresses.
Yes.
So there's this link local one at the bottom, which is even if no one is trying to provide you with IPv6, devices on the network will assign one that only works on that network. So if you had 2 devices on your home network that wanted to communicate with each other over IPv6, that would work.
I see. Okay.
It's these ones that begin with 2 something something are the public ones.
Okay, thank you.
So what you would expect if you had IPv6 from your ISP is, in addition to that FE81, some others would appear in addition.
Okay, thanks.
Cool.
Yeah, I guess I'm not that lucky. Mine has got, as well as the FE81, it's got an FD4D.
Which one? FD4D?
Yeah.
That's an interesting one.
That's on a Raspberry Pi.
Yeah. The FD ones are not something I would expect someone who hadn't deliberately chosen that. There's something going on there. Message me later. We can have a look at stuff. All right.
One last question, maybe. Anyone else? No. Thanks, Ben. That was
Cool.
thought provoking. I did try to ping you, but I missed the last bit of your address. I don't think I have IPv6 on my PI anyways.
Okay.
Thanks.
Yep.